Hello everyone, this is Steve. Thanks for joining me for another example. I don't know if you watched the previous example, but on the previous example I had actually made a mistake when I wrote the equation where I had put an equal to on the same number in two different pieces of the equation. See how this negative 3 has an equal to on it right here? That means this negative 3 in the second equation cannot, like it doesn't. And you see how this x is greater than or equal to 2 has an equal to? That means this one cannot. Now it's actually okay if they're both missing the equal to, it just means that there would be a hole in your graph. So this one looks good, so let's go ahead and draw it. All right, these pieces look a bit more complicated, so at least the first one and the third one do. Let's figure out what's going on here. We got y equals negative 2x minus 5, and because of this negative 3 here, I'm definitely going to plug a negative 3 in. Negative 2 times negative 3 is going to be 6, minus 5 is going to be 1. I get the order pair negative 3, 1. And because of the equal to, it's going to be a solid point. Now, I don't have another endpoint because this just hangs out to the left of the ordered pair negative 3, 1. So it's going to shoot off to the left in some direction, but I do need a second point. So what I do is I pick a second x value, and I make sure I pick one that is less than negative 3. Like negative 4, that would work. Negative 2 times negative 4 is 8, minus 5 is 3. You could have also done negative 5, by the way. That would work just as well. Because either way, you're going to get a couple more points on the graph. So we got negative 4, 3 right here, and negative 5, 5 up here. Either way, because of the inequality not being a compound inequality, since it's just x is less than or equal to negative 3, that means this one's going to just go forever and ever in that direction. So we put an arrow on it. All right, that takes care of our first piece. Let's erase this. You can always rewind if you need to see it again. Second piece, between negative 3 and 2, check this out, everyone. Between negative 3 and 2, no equal to, so hollow points on each end. And the equation is just f of x equals 1. That's a horizontal line. Wait a minute here. Uh-oh. You know what? You see this goes like this, and I know there's a hollow point there at the 2, but there's also supposed to be a hollow point here. So what do you do? What do you do when there's a hollow point and a solid point in the exact same spot? Turns out the solid point wins. So you can feel free just to leave that solid point there and just run this piece right up into it, like that. That actually takes care of the second piece. It's at a height of 1, because of this 1 right here. And normally it would have a hollow point on each end. Can I make this look a little better here? But since it hits a graph that has a solid point at the end, then the solid point just covers up the hollow point. All right, last piece. Negative 3x plus 7 for x greater than or equal to 2, which means not only am I going to plug a 2 into negative 3x plus 7, I'm going to plug some number bigger than 2 into it. Because it says x is greater than or equal to 2, so we could do a 2, and we could go ahead and do a 3. Try 4 if you want. So if we plug a 2, negative 3 times 2 is negative 6, plus 1 is 7. Negative 3 times 3 is negative 9, plus 7 is going to be... 9 plus 7 is going to be negative 2. There we go. And if we put a 4 in there, negative 12 plus 7 is going to be negative 5. Okay. These are all going to be solid points. Let's see. Let's do green. Got 2, 1. Darn it. Look at this. It's supposed to have a solid point right here. And then 3, negative 2. And then 4, negative 5. You know what? That's another solid point covering up a hollow point. So, oh my gosh. Okay, so we'll just go ahead and change that to the solid point. And you know, it doesn't really matter with the colors. When you draw these, it might all be the same color. In fact, I'll do it all in the same color in just a moment here before we walk away. This one just keeps going forever and ever and ever because it's just a one-sided inequality. But when you draw these all in one color, everyone, you're not even going to really see those hollow points that were there because it's just going to look like this. So this is a piecewise function where all the pieces are touching. Little trick here, of course, it makes us think we're doing something wrong, but we actually didn't do anything wrong. We took care of it. And this problem's done. I hope that helped. Thanks for watching.